Hello everybody. Today I'm going to be showing you a little bit about base and height of triangles and also how to calculate the area of triangles. So first, I have some examples of triangles up here. Triangles come in many different, I don't want to say shapes because they're all triangles, but many different formats, maybe you would say. But every triangle has a base and a height. Usually, we like to orient our triangles so that the base is on the bottom, although we certainly might see a triangle that looks like this or that looks like this, so we don't have a side that is necessarily like horizontal on the bottom. We could just turn the triangle if we needed to make the horizontal flat side be on the bottom, and we will call that the base. Then every triangle also has a height, and the height is the line that extends from the base straight up at a 90-degree angle to the top point of the triangle, to the highest peak of the triangle. So in some triangles, the height is actually one of the sides of the triangle, and the base is another side. That is in right triangles where you have a right angle already in the triangle. Other triangles do not have a side that could work as a base because they're not at a 90-degree, that could work as the height because they're not at a 90-degree angle to the base. So you might have to go from the very top peak straight down and draw in sort of an imaginary line here that's at a 90-degree angle to the base, and that would be considered your height. Other triangles have like this kind of overhang. And again, neither of these two sides is at 90-degree angles with the base, so we would have to go from this highest peak straight down, and we could even extend imaginary line here out from the base so that there's a nice 90-degree angle here, and this measurement would be your height. Okay, that's going to be important moving forward. So how do you find the area of a triangle? You can imagine that you are doubling your triangle. We talked about how a triangle is half of a parallelogram. So with some triangles, it's pretty easy to imagine like flipping this over, duplicating it, and filling in this space so that I have a rectangle or a parallelogram, specifically a rectangle. And I can calculate the area of this rectangle. 1, 2, 3, 4, 5. 1, 2, 3. 5 times 3 is 15. And that would be the area of the entire rectangle, but this part doesn't actually exist. I only used it to help me find the area of the rectangle, so I only need half of that area. I'm only interested in the triangular part, which is half. So I would take 15 and divide it by 2 to get my area of 7.5 square units. Other triangles are a little harder to double or to duplicate, so you might use tracing paper. I traced over this triangle, and I can see that if I flip this around and put this piece, line up the base, I have a parallelogram. It's still kind of hard to find a base and a height measurement here though, because these are oblique lines, they're on an angle. I can't just count how many like boxes it passes through. It doesn't work that way. I could do this though, and this gives me a parallelogram with a base and a height that I could count. 1, 2, 3, 4 for my base, and the height straight up from the base to the highest point or to the top part of the parallelogram. 1, 2, 3, 4. So 4 times 4 is 16. Again, I'm not interested in the whole parallelogram. I only want half of it. So I could take the 16, divide it by 2, and get 8 square units for the measurement of this parallelogram here. Of this triangle, sorry. For that last example, where I had this strange overhang here, again, I am going to use my tracing paper and trace the triangle, and then try to figure out how I can swirl it around, twist it, rotate it is a mathematical term, to make a parallelogram where I can use the measurements. So here I have a parallelogram, I have a base of 2, and I have a height also of 2. So I'm going to move this so that I can write on the paper. 2 times 2, that's my base times my height. That's 4 square units, but that, again, was that whole parallelogram. And I don't really want the whole parallelogram. I'm only interested in half of it. So I will take the 4 and divide it by 2 and get 2 square units. So all of this is all like well and good, drawing parallelograms, doubling them, drawing triangles, I mean, and doubling them to make parallelograms. But there's a faster way. And if you'll notice, in every case, we took the base times the height of the parallelogram, which is also the base and the height of the triangle. Multiplied them together and then divided by 2. This was the base. This was the height here. Base times height divided by 2. Here we had a base of 2. We had a height of 2. Base times height divided by 2. So the formula for finding the area of any triangle is base times height divided by 2. You might see that written as base times height divided by 2 as if it were a fraction, or sometimes you see it as 1/2 times the base times the height, because, as we've talked about in class, dividing by 2 and multiplying by 1/2 are the same, give you the same result. They're equivalent operations. So this is the key to remember. That will save you some time and some work. You don't have to draw an additional triangle. You don't have to use tracing paper. Just go straight to the formula.